All right. Okay. Good morning, everyone. Thanks for joining. I think we have several hours of lectures for the next few sessions, so I appreciate everyone staying with me on these. We're going to get started this morning with obstructive sleep apnea. And these are our objectives. We're going to start by talking a little bit about just the physiology of sleep apnea and its consequences. We'll go through the workup of sleep apnea and the symptoms, and then we'll also go through some medical and surgical treatment. So really, when it comes to our specialty in otolaryngology, this slide is not meant to be exhaustive, but it kind of breaks down the categories of sleep disorders. For our purposes, we really focus mostly on obstructive sleep apnea, but it is important to just be aware of these different categories that exist for patients with sleep disordered breathing and also different types of sleep disorders that are out there. One of the things that you should be familiar with are hypersomnias of central origin and narcolepsy, which we'll talk about a little bit more in detail later in the presentation. Circadian rhythm disorders, something that we see commonly with patients that have if they're shift workers or if they work in factories or they have off schedules that are not typical for the normal patient population, we may see circadian rhythm disorders in those patients. Parasomnias is something that you should be familiar with. These are patients that potentially have EEG changes, but are not necessarily associated with hypopneic or apneic events. The two types of parasomnias that we often see are sleep hallucinations, and there's two specific types that I recommend you be familiar with. One are called hypnopompic hallucinations, which occur right when patients arise out of REM sleep before wakefulness, and hypnagogic, which happens just before or prior to patients falling asleep into the deeper stages of sleep. And those are parasomnias. Sleep-related movement disorders, patients that have restless leg syndrome, patients sometimes are associated with certain types of electrolyte abnormalities or iron deficiencies. And anything that, as we go through the presentations this morning, anything that's sort of either in a different color or highlighted is something that I just recommend you sort of commit to memory. And this is a slide where I would recommend just memorizing these definitions, right? So an obstructive apneic event is defined as cessation of airflow for at least 10 seconds with an effort to breathe. And that's contrasted to a central apneic event, which carries the same definition, but there's no effort to breathe. And here's another important slide. There is some variability in the literature when we look at the definitions of hypopneas, but for our purposes and within the otolaryngology literature, I really recommend kind of committing to memory the CMS definition, which is really defined as a 30% reduction in airflow for at least 10 seconds with a 4% oxygen desaturation. There are different definitions by both the Academy of American Sleep Medicine and also some variations of literature if you look at the family medicine literature, but really the CMS definition is what is recommended. And really to sort of understand this, when you look at a PSG, there are two lines that were going to be critically important for looking at the definition of hypopnea or an apnea. And that's the EEG line and the airflow monitor. To have a true apneic event, both the EEG line and the airflow line have to be flat. But if you have an EEG line with some movement, but an airflow monitor that is not flat, that's more of a hypopneic event. And we'll get into and that's because the hypopneic event really does not have the complete cessation of airflow. It's a reduction, but it's not an absence. And as you go through sort of your preparations and your studies, I think it's important to kind of look at what the question or the stems are asking. And also when you look at a PSG, you should look at the different types of things that come up on this report. And one of those important differentiators, and this is especially helpful for differentiating patients that have obstructive sleep apnea from something that we call upper airway resistance syndrome, is to look at the RARAs. And the RARAs are defined as respiratory effort-related arousals. And these are patients or episodes where there's increasing respiratory efforts that result in an arousal, but they don't meet the criteria for true apneic or hypopneic events. So you'll see an arousal, which is usually an abrupt change in the EEG frequency for at least 3 seconds. But you won't see that criteria, the definition, like we mentioned before, for either a hypopnea, where there's a cessation or reduction in airflow, cessation for apnea, and a reduction in a hypopneic event. And I do have a primer, which I'll forward to the Osler staff. And that primer actually goes through PSGs, and they actually break down the different types of lines that we should be looking at, specifically when it comes to what we call the epic. And the epic is a 10-second read on the PSG. And that really is how we are able to break down these different categories into apneic events, hypopneic events, raras. So important to kind of review those so you understand how to read the small epics within a PSG. And this is kind of what I was alluding to before. So when we look at sort of what the question is asking and what the data comes out on the PSG, we need to understand exactly what the crux of the question is and really what kind of information we're trying to gather. So for patients that have OSA, obstructive sleep apnea, or central sleep apnea, we're more focused on the AHI, which is the number of apneic and hypopneic events per hour of sleep. That's different from the RDI, which is also known as a respiratory disturbance index. And that calculates the AHI plus the raras. And the RDI really comes into play when we're looking at patients that may not meet the criteria for obstructive sleep apnea, but may meet the criteria for upper airway resistance syndrome. These are hopefully just review and kind of straightforward definitions. The sleep latency is simply the time to fall asleep, and sleep efficiency is the total sleep time over the total recording time. The sleep latency, generally speaking, in a normal patient population and in a normal PSG should be about 15 minutes, and we'll discuss why that's important. And sleep efficiency is really telling you how good the study is. How effective has this PSG been for what our purposes will be then to go ahead and initiate treatment, whether it's for CPAP or whether we're trying to get approval for surgery. Sleep efficiency, ideally, for a good PSG study with optimal data, you're looking for about 75%, and that's in the adult population. In the pediatric population, we tend to tolerate sleep efficiencies of around 50% because it can be very challenging for children to have an adequate recording time. If you're looking at a full 8 hours, they're not usually able to keep the monitors and all the